Hello everyone, hope all of you are doing well. In today's session, we are going to continue our journey on relation and function, and in today's session, we are going to discuss about inverse relation. Now, this particular session is very important from your examination perspective for two reasons. Of course, this question is actually important, that what is inverse relation. At the same point of time, we have to understand that there is a difference between inverse relation and symmetric relation, and in today's session, we are going to decode what is the difference exactly between the inverse relation and symmetric relation. And also a humble reminder to all my viewers and the new viewers that all the relations that I have discussed prior to this are pinned in the description, so do go ahead and watch those videos as well. Now, without any further delay, let's get started. Now, first of all, let us understand what do you mean by inverse relation. First of all, let me explain you with a very simple example. Say suppose we have a set that is A and it contains two elements, suppose 1, 2. All right, and we have a relation, say suppose 1, 2. This is our relation and it has only one ordered pair, that is 1, 2. Now we have to understand that the inverse relation, in case of inverse relation, the inverse relation is represented by R inverse, that is R to the power -1, and in this relation the ordered pair that you will have will be swapping of those two elements that is there in the previous relation. Okay, so primarily we can see that the ordered pair that was formed in this particular relation was 1, 2, and so in this case we will have it as 2, 1. All right, so this is what inverse relation is. Now let us try to understand the same, how we can express this mathematically. So if you can see here in this definition, if x, y belongs to R, that is R is the relation, then that will implies both sides that y, x should belong to R inverse. If this is the situation, then this is known as inverse relation, and this is how we are going to express it mathematically during exams. If you want to understand how the swapping happens, then you can understand this with a simple example here again. As you can see in this particular relation, we have some ordered pairs. We have 4 ordered pairs in exactly. I'll also show you how the Cartesian product is happening in this case so that you can have a clear picture. So in this particular case, we can see that we have 4 ordered pairs in this particular relation. Say suppose it is R, and if we want to form the inverse relation, that is R inverse, then what you need to do is that the new ordered pairs will be formed by swapping the elements of the previous relation ordered pairs. All right, now say suppose we have two sets A and B, and the elements contained in set A are A, B, C and D. All right, and the elements contained in the set B are 1, 2, 3 and 4. Now clearly we know that in order to perform the Cartesian product of the two sets, we have to map the elements. Okay, I have already explained the mapping countless number of times in my previous videos. Now I will not discuss it again here. Now you can see that this particular ordered pairs that are formed here are actually the resultant of mapping. All right, from the elements of set A to elements of set B. All right, so we do the mapping and we get the resultant relation here. But a small question to all of you, if you can pause the video and just tell me how many ordered pairs we will get here after doing the Cartesian product of the set A with B. So I hope that you have already answered it if you have paused it. And for those of you who don't know that how many ordered pairs we'll get, it will be a simple trick we follow here, that is the number of elements contained in set A is 4 and the number of elements contained in set B is 4. So the resultant ordered pairs will be 16. All right, so 16 ordered pairs we will get, and let me show you a couple of them so that you can have a clear picture. So A will be mapped with 1, similarly A will be mapped with 2, A will be mapped with 3 and A will be mapped with 4. All right, in this way we will get the first 4 ordered pairs like A, 1, A, 2, A, 3 and A, 4. Now this is my first 4 ordered pairs, and similarly if you map the remaining elements of set A with B, you will get the remaining 12 ordered pairs, which I'm not going to write as of now because you have already got the gist of this. And the inverse relation in this case, as you can see, is that it is obtained by swapping the elements with each other. So this is what inverse relation is. Now let us try to understand by the end of this session that what is the difference between symmetric relation and inverse relation. So let us take for instance a relation that is 1, 2 and 2, 1. Now in this case, this particular relation will be called as symmetric relation. Why? Because in this relation we can see that for the ordered pair 1, 2, we have another ordered pair where we have swapped the elements. Now this is called symmetric relation because this swapped elements ordered pair is in this particular relation. All right. Understand this again very clearly, because the swapped elements are there present in this very relation. That is why it is called symmetric relation. However, in case of inverse relation, suppose we have a relation r equal to 1 comma 2, then the inverse relation will be formed by a different relation. Okay, it becomes a totally a different relation, and then we will have 2 comma 1 in this particular relation. So this is the difference between inverse and symmetric relation. I hope that you have understood in very simple words. In symmetric relation, the swapped elements will be found in the same relation. However, in case of inverse relation, a totally different relation is formed where you will find the swapped elements. All right. Now, one more noteworthy thing to be mentioned is that you have to understand that the domain of, it's very important that you remember this, that a domain of inverse relation is exactly equal to the range of relation. Okay, the existing relation that we have. So the domain of the inverse relation will be equal to the range of the existing relation, and exactly the same thing happens in a reverse manner in case of range of inverse relation. So the range of inverse relation will be exactly equal to domain of R. Okay, so this is a very important thing, and you can obviously cross check it by taking some examples or taking the same example that I have taken. You can understand it thoroughly. If I have to mention it in very simple words, we can say that the elements A, B, C and D are the elements from the domain. Clearly we can see it. However, we can see that in case of inverse relation, this particular elements of domains come in the position of the elements of range. As we can see that the second element of the ordered pair is often considered as the elements of the range. So that is how this particular relation is formed, where we say that domain of inverse relation is equal to the range of relation, existing relation, and the range of the inverse relation is equal to the domain of the existing relation. So this is the video, guys. I hope you had an insight regarding what do you mean by an inverse relation in details. Also, you have understood what is the difference between inverse relation and symmetric relation. I believe that I have covered everything about inverse relation, but still, if there is any doubt left in your mind regarding this particular session, do feel free to comment in the comment section. I'll definitely try to address it. And once again, yes, I'm telling you this, that this particular channel is dedicated specially for the English viewers. In near future, we might come up with a Hindi channel, of course, looking at the viewership, if we can reach out to a wider audience. For that, do hit the like button if you like the video and if it adds any value to your preparation. And till we meet next time, God bless you and thank you all.